In Algebra 1, Section 8.2, we're dealing with quadratic functions. So it's what you've been dealing with the x squared plus bx plus c. It's called quadratic functions, if you remember me stating in the video. Now what we're dealing with is just you can see the graphs, because like I told you, it's not a straight line like the y equals mx plus b. This graph of a quadratic function is a parabola. So basically it's this U-shaped graph. Okay? It'll hit a certain peak and then it'll mirror itself back the opposite direction. Now you know it's a squared plus b squared equals c. This graph opens up, okay? But this graph, negative ax squared plus bx plus c, it opens down. So if the a is negative, then you'll see a downward parabola. If it's positive, then you'll see an upward parabola, okay? So the answers, or the solutions to parabola, okay, when we're solving them, is the x-intercept. So where it crosses the x is actually where it crosses the x is the x-axis right here, is the solution for the problem. So sometimes it won't touch the x at all. That means that there's no solution. And most of the time it'll touch twice. It'll touch once going down, and then it'll touch once going back up, or once going up and then once going back down, okay? And then you also have the case where it touches right at one of its peak, either this way the peak or the peak up. Then that gives me only one solution because it only touches it at that vertex, okay? So this middle part right here is called the vertex. I don't know if that's labeled. Okay, that point is the vertex, and the vertex is right here, okay? And then on the vertex, there's this line that's called the axis of symmetry. What that means is if I have a mirror, okay, right here, however far this point is from the axis of symmetry, this point is the same distance, okay? So it like mirrors each other. So my next one, where is it? Right? So in order to find my axis of symmetry, I can use an equation by doing x equals negative b over 2a. So if I have an equation here, whichever equation, and I plug in negative b over 2a, I can find the axis of symmetry. I can find the exact midpoint line where the parabola is split in half, okay? So remember that equation. We're going to be using it. Let's slide this over here. And we're going to do some problems. Don't forget to write it. Like, pause right now. Sorry. And then write it. I'm not going to edit that out. Because you must know I'm human. Okay. So, it says number 1, it says find the axis of symmetry and zeros. So basically, if I look at this graph, the axis of symmetry is right here. So the axis of symmetry is where it's cut on the x-axis. So here's my x and here's my y. Because it's cut right here, okay, this is the axis of symmetry equals 0, because it's cut on the 0 line. If it was moved over here, it would cut wherever x is. Okay? Oh, there was one more thing, sorry. On this right here, there's something called a maximum and a minimum. So you see how this peaks right here? So that means the highest number on the y it'll hit is 0. So this parabola will max out at 0 at the y value. So max and minimum are at the y. And then right here is the minimum. And since the minimum goes as low as 8 on the y value, then it's a minimum at 8. So your vertex is actually your axis of symmetry is your x value, and your y value is your max or min, right? That's an important one. Okay? And if this is all confusing to you, you'll slowly get into it when you start doing problems. So, slide this on over again. Okay, so in this case it says find the axis of symmetry in 0. So we found the axis of symmetry because that's the where in the x it's cut in half, and that is 0. So the next one is finding the zeros. Well, I know because it hits x twice. It hits x at -1 and positive 1. Its solution is, so its zeros are -1 and 1. Now this is not a point. It's not -1, 1. It's not a point because these are both x values for the x-axis. Okay? If I wanted to find the axis of symmetry of this equation right here, it doesn't give me a graph, and I could graph it out, but what I'm going to do right now is just focus on this equation that they gave us right here. So the equation of the axis of symmetry is x equals -ba. So my equation is y equals ax plus b, ax squared plus bx plus c. In this case, it's negatives, so we know it opens down. So we know that a equals -3. We know that b equals 10, and c equals 9. So I need to plug into this equation. X equals -b, so -10. So if b is already a negative, then it will cancel out to be positive. Keep that in mind. And 2 times a, which is -3. So it would be -10 over -6. These negatives cancel out, making it 10 over 6, and I can reduce it, divide both top and bottom by 2, so 5 over 3. All right, that's my axis of symmetry. So if I put that in decimal, what this means is I put it in decimal, so it's 1 point something. I would find it on the x, 1 point, so positive 1 point something, and then that's my axis of symmetry. So that means my parabola is copied from one side to another. It mirrors on that axis of symmetry. So the next one is they want us to find the vertex. So remember, the vertex is not just a number, it's an x and y value because it's a point somewhere on the graph. This would be my vertex. And my vertex here would be, so my vertex would be 0 on the x and up 2. So 0, 2. That's my vertex. So if I look here, it tells me that the x value is my axis of symmetry, right? So if I can use this equation to find my x, then I can plug it in to solve for my y, and then I have my vertex. So my equation of axis of symmetry will also help me with my vertex. So I'm going to put it into my equation. This is my a, this is my b, this is my c. So I'm going to do x equals -b, so -6, over 2 times a, which is -3. So this would be -6 over -6, which gives me +1. So that means my vertex, my value is 1 for x. So in order for me to find the y, all I need to do now is plug in x. So -3 times 1 squared plus 6 times 1. Remember, there's more than one x that I'm plugging in. And because both of them are x, that means they are the same number. -7. So powers come first, and this squared, because this is in parentheses, this squared only applies to the 1. It does not apply to the -3. That's a common mistake that's made. So then 1 squared is just 1, plus 6 times 1 minus 7. So -3 times 1 is -3. 6 times 1 is +6 minus 7. -3 plus 6 is +3. Minus 7 is -4. Right? So my answer, -4, is not -4 or 1. It's 1, -4. So that means this would be that point to this graph. The point where it's either the top, the highest point, and it changes direction, or it's the bottom point and it changes direction. All right? So go ahead and try page 353, numbers 8, 10, and 14. 353, numbers 8, 10, and 14, and I will see you in class.